PBS light waves. Number 1, let there be light. Unlike sound or earthquakes, light waves can transfer energy anywhere, whether there is a medium to carry it or not. Light is all around you with wavelengths bigger than mountains and smaller than atoms. But your eyes can see only a tiny part of those light waves, the visible light. So in other words, even when it's dark, there are other light waves you can't see that are going around you, bouncing off of you, and even going through you. Waves transfer energy. Mechanical waves, like sound, earthquakes, or waves on a pond, transfer energy by vibrating actual particles. But there is another type of wave called an electromagnetic wave, and just like a ripple on a pond, electromagnetic waves have wavelengths, frequency, and amplitude that can be measured. But instead of surveying them, we can see some of them. Electromagnetic waves are light waves. And the unique feature of light waves is that they can transfer energy even when there are no particles to be found. Put a light bulb, a firefly, or say the sun up in space, and that light energy will travel even though there are no actual particles. Once those electromagnetic waves get to our little planet, they react with the matter here on Earth to continue that energy transfer. And thank goodness they do, because we here on Earth rely an awful lot on that light energy from the sun. Question number 1. What are electromagnetic waves? Possible answer choices: a medium, light waves, or waves in the water. Pause and answer the question. Number 2. What are the 3 characteristics of electromagnetic waves that can be measured? Choose all that apply. Possible answers: wavelength, frequency, amplitude, light, sun. Pause and answer. Number 3. Light is a type of transverse wave with wavelength, frequency, and amplitude, and it does not need a medium to travel through. Important vocabulary: absorb, to take in energy, such as light or sound, and transform it into another type of energy, such as heat or motion. Amplitude, a wave's intensity, the maximum distance a wave carries the particles of a medium from its original position. Electromagnetic spectrum, the entire range of frequencies and wavelengths of light energy. Electromagnetic wave, or light wave, a disturbance that can carry energy from one place to another through either a medium or a vacuum. Energy, the ability to do work. Examples of energy include light, sound, heat, and electricity. Frequency, the number of waves produced during a given amount of time. Mechanical wave, a disturbance that carries energy from one place to another through a medium, a liquid, solid, or gas. Medium, matter, such as a liquid, solid, or gas, that waves carry energy through. Particle, a minute or tiny portion of matter. Reflect, to bounce off. Refract, to change direction when moving through one medium into another. Transverse wave, a wave in which the particles of the medium move in a direction perpendicular to the direction the wave itself is moving. Wave, a disturbance that carries energy from one place to another. Wavelength, the distance between any point on a wave to an identical point on the next wave. Here is the question for number 3. What is the difference between a mechanical wave and electromagnetic wave? Possible answers: a mechanical wave can travel through empty space. An electromagnetic wave needs a medium to travel through. Or, a mechanical wave needs a medium to travel through. An electromagnetic wave can travel through empty space. Pause the video and answer the question. Number 4. You can refer to question 3 to find your answer. Here's the question: what is the difference between a wave and energy? Possible answer choices: energy carries a wave. A wave carries energy. Energy is a disturbance, but a wave isn't. Pause to answer the question. Number 5. Refer to question 3 to find the answer. Question: what is the difference between absorb and reflect? Possible answer: absorb means to take in energy, and reflect means to bounce off. Other answer choices: absorb means to bounce off, and reflect means to take in energy. Pause and answer the question. Number 6, refer to question 3 to find the answer. Question: what is the difference between reflect and refract? Possible answer choice: reflect means to change direction, and refract means to bounce off. Possible answer choice: reflect means to bounce off, and refract means to change direction. Pause and answer the question. Number 7, the electromagnetic spectrum. Light waves come in a whole range of frequencies and wavelengths, from radio waves as big as mountains to gamma rays smaller than atoms. Regardless of size, all light waves carry energy, and each is useful in its own way. Scientists have organized all of this energy into a table called the electromagnetic spectrum. Electromagnetic wave transfer energy in a transverse fashion. So just like a mechanical transverse wave, electromagnetic waves can have long or short wavelengths and high or low frequencies depending on how much energy the wave is carrying. And all of this light energy, called radiation, has been arranged by scientists into a nice little chart called the electromagnetic spectrum. Arranged by frequency, the radiation ranges from low energy radio waves to microwaves to infrared radiation to visible light, followed by ultraviolet light, X-rays, and finally to gamma rays, which have the highest frequency and therefore the highest energy. The electromagnetic spectrum is the entire range of wave frequencies and lengths that light energy can travel, and we humans can only see this tiny part with our eyes. But we can feel this part, the infrared heat or the ultraviolet sunburn, with our skin, and have created instruments to hear this part, radio waves, with our ears, and cook our food using this part, microwaves. We use X-ray radiation to see inside our bodies and create gamma radiation in our nuclear power. All in all, our lives are connected to the electromagnetic spectrum, whether we like it or not. Question: list the 7 parts of the electromagnetic spectrum from lowest frequency or largest wavelength to highest frequency or smallest wavelength. We have micro, radio, gamma, infrared, ultraviolet, visible, and X-ray. You will put the lowest frequency or largest wavelength on top and the highest frequency or smallest wavelength on bottom. Pause and answer the question. Number 8, match the words with the sentences that they fill in the blank for. Refer to question 7 for help. The lowest frequency waves on the electromagnetic spectrum are blank waves. The highest frequency waves on the electromagnetic spectrum are blank waves. Blank waves give us sunburns. We feel blank waves on our skin as heat. The tiny part of the electromagnetic spectrum that we can see is blank light. Doctors use blank light waves to see our bones and teeth. Blank light waves are useful for cooking. Here are the answer choices: infrared, microwave, visible, X-ray, radio, ultraviolet, and gamma. Pause to answer the question. Number 9, visible light. Although the electromagnetic spectrum covers a wide range of wavelengths of light, we can see just a small portion of these wavelengths. The scientific term for these viewable wavelengths, which we call colors, is visible light. Consider a rainbow. Although it may seem magical, what you're really seeing is an incredibly accurate visual representation of the electromagnetic spectrum. Each of these colors your eyes detect is an example of different wavelengths and different frequencies of energy being transferred from the sun through the vacuum of space, refracting through the particles in the atmosphere, entering your eye, and being processed by your brain. And incredibly, the light we see is only a tiny fraction of the electromagnetic energy traveling all around us and even through us. Humans can detect wavelengths between 700 nanometers red and 400 nanometers violet with our naked eyes. These wavelengths are what we call visible light. All other wavelengths of electromagnetic radiation are invisible to us. We can't see it even though it is there. So although a rainbow may seem magical, the two little energy detectors in your head, your eyes, deserve some credit too. Question: a blank is an accurate representation of visible light. Possible answer choices: eye, energy, rainbow, electromagnetic spectrum. Number 10. Refer to question 9 to answer the question. Question: a or an blank is an accurate representation of visible light. Electromagnetic spectrum, rainbow, eye, energy. Pause and answer. Number 11. Refer to question 9 to find the answer. Question: your eyes see different wavelengths of light as different blank. Spectrums, colors, amplitudes, detectors. Pause and answer. Number 12. Your eyes see different wavelengths of light as different blank. Possible answers: colors, amplitudes, spectrums, detectors. Pause and answer. Number 13. Refer to question 9 to find the answer. Parts of the electromagnetic spectrum that humans cannot see are called blank. Possible answer choices: visible, magical, dark, invisible. Pause and answer. Number 14. Refer to question 9 to find the answer. Humans detect light energy with their blank. Possible answer choices: ears, eyes, brain, hands. Pause and answer. Number 15. Reflection and refraction. When visible light waves hit an object, they will interact in one of three possible ways. The light waves will 1. Bounce off the object, 2. Go through the object, or 3. Soak into the object. When you look at something like an apple, you are not exactly seeing that apple. What you are seeing is light energy interacting with the apple, being detected by your eye and interpreted by your brain. Different objects have different properties that absorb, reflect, and even allow light energy to pass through. But not all wavelengths of energy do the same thing in every given object or medium. This red apple absorbs all visible wavelengths of light energy except the red. The result: red wavelengths are reflected to our eyes and the apple looks red to us. A green apple looks green because it reflects the green wavelengths. Some matter allows light energy to go through it, a glass of water, and as it does, the energy interacts with the matter and its speed and trajectory change depending on the angle it hits. This is called refraction. The result: the cool broken straw illusion, why you are no good at spearfishing, and best of all, the lens on your eyeball that allows you to see. Question: which word matches this definition? To take in energy, such as light or sound, and transform it into another type of energy, such as heat or motion. Reflect, absorb, or refract. Pause and answer the question. Number 16, refer to question 15 to find the answer. Which word matches this definition? To change direction when moving through one medium into another. Absorb, refract, or reflect. Pause and answer. Number 17, refer to question 15 to find the answer. Which word matches this definition? To take an energy such as light or sound and transform it into another type of energy such as heat or motion. Possible answer choices: absorb, reflect, or refract. Pause and answer the question. Number 18. Refer to question 15 to find the answer. When light blank an object, it is reflection in action. Possible answer choices: bounces off, goes through, soaks into. Pause and answer the question. Number 19. Refer to question 15 to find the answer. When light blank an object, it is refraction in action. Possible answer choices: soaks into, bounces off, or goes through. Pause and answer the question. Number 20. Refer to question 15 to find the answer. When light blank an object, it is absorption in action. Possible answer choices: goes through, soaks into, or bounces off. Question 21. Refer to question 15 to find the answer. A green apple looks green because it blank the green wavelengths. Refracts, absorbs, or reflects. Pause and answer the question. Number 22. Light that refracts when it goes through a glass of water, blank. Possible answer choices: changes speed and direction, or changes to another type of energy such as heat. Refer to question 15 to find the answer. Pause and answer the question. Number 23. Refer to question 15 to find the answer. When an object absorbs light energy, it reflects blank. All of the colors, only the colors you see, or none of the colors. Pause and answer the question.